All right, question 1 for the practice quiz on lesson 24. So in triangle ABC, measure of angle B is equal to 59 degrees. The distance of AB is equal to 7 units, and the distance of AD is equal to 6 units. The altitude, segment AD, is also a segment bisector of segment BC. What is the area of triangle ABC? So in order to find the area of a triangle, you need to know the length of segment BC, because triangle ABD is a right triangle and segment AD bisects segment BC. You can use your knowledge of right triangles to find the distance of BD and then find the distance of BC. So what they are saying is that we have a right triangle, and there are some tools that we have in order to find side lengths of right triangles. So is it a right triangle? Yes. Am I solving for a side length? Yes, I'm solving for a side length BD. So there are a few tools that we can use to solve for side lengths. We can use the Pythagorean theorem, or we could use the trig functions like like sine, cosine, and tangent. Those all try to come out at once. So we have the trig functions. Now we have to know not only the tool, but what we have to have in order to use the tool. So to use the Pythagorean theorem, we have to have at least 2 known side lengths. And to use the trig functions, we have to know 1 side length and 1 other angle besides the 90-degree angle. So I'm looking at this triangle, and we have both. We have 2 known side lengths, we have 1 other angle, and at least 1 side length besides. So we can choose which one we want. I will show you both and show you some of the strengths of trig functions and some of the downfalls of Pythagorean theorem, I guess. So it just depends on which situation you want to use it in. So again, trig functions are sine, cosine, and tangent. I remember my ratios by using the mnemonic device of SOHCAHTOA. Sine is opposite divided by the hypotenuse side length. Cosine is the ratio of the adjacent side length divided by the hypotenuse side length. And tangent is the adjacent side length divided by the opposite side length. So I guess the first question is, well, what am I looking for and what angle is given? Or what is my perspective? What am I looking for and what is given? The perspective. Well, 59 degrees or angle B is given, so I'm going to first label the triangle based on that. So the hypotenuse is always going to be across from the 90 degrees, so segment AB is the hypotenuse, and then the segment across from the angle, AD, is the opposite. And that means that segment BD is our adjacent. So what are we looking for? Well, right now it wants to know what the length of segment BD is rounded to the nearest tenth. So I'm looking for the adjacent side length. So since we have both the hypotenuse and the opposite side length, there's, as you go through this, you might have more than one trig function to use. So I'll just go through and step you through how I determine which trig function to use. So sine is the ratio of the opposite side length divided by the hypotenuse side length. We have both of those, and it's not helping us find what we're looking for, which is the adjacent side length. So I'm not going to use the sine. Cosine is the adjacent side length divided by the hypotenuse side length. Well, I am looking for the adjacent side length, and I have the hypotenuse side length, so I'm going to use that. So we would have cosine of 59 is equal to the adjacent side length divided by the hypotenuse side length, which is 7. So in order to solve for A, the adjacent side length, I would multiply both sides by 7. So 7 times the cosine of 59, and I would multiply this side length by 7 as well. The reason for that is because I have a knowledge that 7 divided by 7 reduces down to 1, and so we're actually left with 7 cosine of 59 is equal to 1a, since 7 divided by 7 reduces down to 1. Typically in math we write a. So it is understood that if we write a, there has to be at least one of them in order for us to write it. So then we would come over to our calculator and we'd say 7 times the cosine of 59. Make sure we are in degrees. 3.60, so rounded to the nearest tenth is 3.6. I'm going to show you with the Pythagorean theorem and show you why sometimes using a trig function can be a strength. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So now that we have that, let's relabel this triangle according for Pythagorean theorem. Now c squared is the hypotenuse again, so it is still side length 7. A and b are just the side length, so this could be b and this could be a, or vice versa. So this could be a and this could be b. I will keep this as a since I used that and I'm not wanting to add in and keep it clear. I'm wanting it to keep it clear. So we would use substitution, and a squared, I don't know what little a is because that's what I'm looking for. B is the value of 6, so we do know that b is 6 and c is the value of 7. So then we would simplify, and so we would have this. 6 squared is 36 and 7 squared is 49. So then we would end up with a squared plus 36 is equal to 49. We're going to keep simplifying. I want a by itself, so I'm going to subtract 36 from both sides. And we have a squared 36 minus 36 is 0. So I'm not writing it. And 49 minus 36 is 13. So then I ask myself, okay, well, a is being squared. What is the inverse operation of a square? And that is the square root. The way I remember that is square and square root. They both have square in it. So we would take the square root of both sides. So we would end up with a is equal to the square root of 13. So if we jump over to our calculator, square root of 13 is 3.605. So we end up with the same answer or same solution. Just notice that while the trig functions took me, let me shrink this so we can all look at it on one page. So while the trig functions took me one step, I multiplied by 7. The Pythagorean theorem took me 1, 2, 3, 4 steps. So sometimes using the trig functions can save you some time. So now that we have that, what is the length of segment BC? So remember at the very beginning they said that segment AD is the bisector of segment BC. What does that mean? It means that this point, this segment cuts it in half, so into 2 equal parts. So this segment and this segment are congruent. We know that this segment is 3.6. Since they are congruent, this segment has to be 3.6. To find the total length of BC, which is this whole segment, we would add them together. So what's 3.6 plus 3.6? That comes out to be 7.2. So now it says review the following solution for the area of triangle ABC. Area of triangle ABC is equal to the distance of AD times the distance of BC times sine of B. Area of our triangle is equal to 6 times 7.2 times sine of 5.9. Then they simplified sine of 59 in this step, and then area of triangle ABC is approximately 37.03 units. So I'm wanting to think back. Do I remember that the area of the triangle is, anytime that you're dealing with the area of a triangle, there will be a 1/2 in there. So since I am not seeing a 1/2, this is not correctly applied. The reason why there's going to be a 1/2 with a triangle is because the area of a triangle actually comes from half of the area of a square, rectangle, or parallelogram. So that's why there's that 1/2 included in the formula, is because the area of a triangle is actually just half of the area of a rectangle, square, or parallelogram, which is your base times height. So that's how I know the 1/2 is going to be in there. The other thing that I check for is the area for using sine. I call it my sandwich method. It's just how I check that I have the right side lengths and the right angle. So since I'm given angle B, I want to make sure that this angle B is sandwiched, meaning that I have the side lengths that are creating that angle, or sandwiching that angle in. In math, it's called the included angle. I just call it the sandwich angle because it's easier for me to remember. So we have segment BC, which was the 7.2, so that was correct. Segment AD is not one of our side lengths that would create this sandwich, so that's incorrect. So I'm looking for a formula that has the segment of BA or AB, however they list it, times BC times the sine of B, because AB is one of those side lengths that sandwiches our angle. So when we look at this, it's not correct. So I'm eliminating these first two. So the formula for finding the area of a triangle by using sine is not correctly applied. Okay, it's good so far, therefore the rest of the calculation is not correct. The correct formula uses AB instead of AD. Correct. This means the correct area is 7 times 7.2. No, because they did not include the 1/2 because we're dealing with a triangle. So I'm just scanning and I see that it says it is not correctly applied. It uses AB instead of AD and has a 1/2 as a factor. Yep, it has all of those. So that's how I would go through this question, and I hope seeing the comparison between Pythagorean theorem and trig functions is helpful and will help you evaluate which one you want to use.